Hello, everybody. Welcome to this week's episode of the Day Zero podcast. I'm Specter. With me is Z. Apologies that we missed last week and are going to be a little bit late this week. My week last week was a bit chaotic. I had a lot going on, mainly preparing for my presentation at Hardware, which I'll get into in a little bit, actually. But yeah, I was working to prepare a demo and things were not going my way for a while. I basically didn't get my demo working until like the night before I left. So I didn't really have a good chunk of time to prepare and record and everything for the podcast. So unfortunately, we did miss last week.
So
But
you didn't have the like your PS5 out on your flight? Because I know you took that with you. So you didn't have
I
that out
did.
on the flight? Oh, you did have it out on the flight?
Oh, no, I didn't have
Oh,
it
you
on the
took it
flight.
with. Yeah.
I mean, the PS5 is way too like stupid and big for anything like that.
No, to
It would
have
have
it on
been
the
funny, but
flight, you're trying to get this last minute demo
yeah.
going.
Yeah,
What do you
I'm
end up
sure
doing
that
for the
wouldn't have been
demo?
annoying for everybody else that was on the plane trying to sleep. But yeah, so for the demo, so the hypervisor exploit allowed us to patch the kernel and everything in the PS5. So the demo was running a payload that would install the hooks and patches necessary to run Homebrew. And then I launched a Homebrew app that showed the Hardware logo, and I actually modified it a bit and made it like shoot lasers when you press the trigger buttons because Teamstar was introducing my presentation, and like the day before I was giving the talk, I was chatting with him and showing the demo because I wanted to work and make sure that the setup that I had would work for the presentation. So I was in the hardpone area. So maybe I should explain a little bit of that. So
Yeah, let's jump into talking about Hardware IO, I guess.
yeah, let's get into hardware. So um yeah, it was in the Netherlands. It moved from The Hague to Amsterdam. So it was a new location for them and everything. It was a little bit bigger than where it was before. I wasn't at it when it was in Hague, but there was a lot of discussion around it. But yeah, so I got there the day before the conference at about noon. Um, and I was able to hang out a bit in the hardpone area. So hardpone, for those who aren't familiar with it, and this is a really cool idea, by the way. Hardpone, the whole idea is Hardware.io brings in some vendors, so they have like Xiaomi. They've have had Meta and Google in the past, but they weren't there this year. But they connect with these different vendors and they bring in some products of theirs for people to hack on. Um, so it's sort of like a CTF, but it's on real hardware. And you can just go into the room. They have a bunch of like soldering stations and stuff to be able to take apart the hardware and extract the firmware and everything. And you work collaboratively with other people that are there to try to like find vulnerabilities and exploit them. And anything that you find, you can then report to the vendor and you like get paid for it. So it's a very cool event. Um,
Almost sounds a
and
bit like Poto. Like obviously it's not as structured and all of that, but that idea of having the vendors involved, having the vendor there, hacking
sort
on
of,
it.
yeah.
I mean, actual software in Ponto. Well, I
So,
guess no, they've had
so for the
hardware.
most part, the vendors weren't there. I think there was a
Oh, okay.
liaison for Xiaomi there, but for the most part, it was just like the hardpone people can help you get in contact with them and whatnot. Um, but yeah, like the stuff with hardpone was really awesome. The people that were there were amazing, and they actually let me use the space a little bit to set up like my PS5 stuff and actually test the setup and get everything working. Um, and they actually lent me a Xiaomi router that they couldn't really use for hardpone because apparently it was so buggy that Xiaomi didn't even want it being used. So they lent me the router and I was able to set everything up in the hardpone area, and then the hotel provided me with a cart that I could put the whole setup on to wheel it into the for the presentation, because I had like four different things going on in my setup. I had the PS5 itself, which was wired to PVR, which so that my laptop could record it or like capture the output. That way, I wouldn't have to like switch HDMI's and stuff when presenting. And then I also had a router that was running like a local area network for running a fake DNS server and running the exploit and everything like that. So I had like 15 different cables and like 4 different boxes and everything all sitting on this table. And it was the most janky thing you'd ever seen. It would have taken me forever to set it back up on the stage. So it was very nice that the hotel had provided the cart and everything for me to just set it up beforehand and take it in. Um, but yeah, so the hardpone stuff was really cool. I didn't get to do too much of it. A lot of my time was spent on preparing for the presentation, but that was the area I spent a lot of time. And then, yeah, I was able to give a presentation on breaking the PS5 hypervisor using some old vulnerabilities. And after that, it was mainly, partying with some people and also talking with a lot of cool individuals, some of which might be listening to the podcast now, because I kind of talked about the podcast a little bit in the presentation as well as in some conversations I had. So, yeah,
gotta
overall,
shill it when you can.
yeah, exactly. And I wore the Spot the Vuln shirt when I gave the presentation, so I did have a hoodie on as well, but yeah. So I was chilling a little bit for day 0 too, but yeah. So I had a really great time. I was actually able to survive the time zone difference, because for those who aren't aware, like Z and I are both in Canada. I'm in the Eastern time zone. What do you, Z, again? You're
We switch between like Central and Mountain
right.
because
Yeah,
we
I was
don't
gonna
do
say
daylight
Mountain.
savings.
Yeah. But anyway, like for me, it's a 6 hour time difference. So I thought I would struggle with it a little bit. And when I went to CCC in 2019, I slept through like half the conference because the time change just screwed me over so much. Luckily for Hardware IO, I was able to go to basically all of it. I managed to catch a few of the talks that were there as well. One that really stood out to me was I forget her name, unfortunately. Let me bring it up on the past events page here.
And for
Um,
what it's worth, while you're doing that, I'll just mention that I think Hardware IO usually gets their videos out after a couple months. I tried looking this
usually a
up.
couple
And
weeks. It's
oh,
usually
was
like a
that
month
quick?
afterwards. Yeah,
Okay, yeah,
last time it was.
okay, yeah, I tried looking it up. I wasn't able to get perfectly on the dates, but I thought it was about a couple months, but might be even better, I guess.
Yeah. So or the speaker I was thinking of was Juhi Kim, and she gave a talk on using speculative execution and like side channels to get around MTE. So that was one of the talks I managed to catch. The keynote was also pretty fun. Again, it was about side channel attacks and kind of the history of them. A lot of side channel like base talks, and that's kind of expected. That has been the buzz in the hardware space for a while.
A lot of a lot of hardware attacks do tend to come down to being side channel attacks like that. I mean, there are the
Yeah,
glitching attacks which go a bit more of a direct attack, but yeah, I mean, side channels are a big part of hardware hacking too.
yeah. So, like I said, I didn't quite manage to catch all the talks that I wanted to because I was kind of busy with some other stuff. I didn't have a ton of time between like preparing for my talk, giving that talk, and then also trying to do some of the hardpone stuff. As a general rule at conferences, I try to keep most of the talks for watching later when they go up online. Um, but it is fun to go to the talks too and like be a part of them. Like it is, I don't want to downplay that. It is a big thing, and uh, I do try to go to ones that I can. So the other thing I heard about the talks this year from talking to different people is they were really happy with the mix. So, like in some past hardware IOs, you know, I mean, it's fair given the name, it's about hardware. But a lot of talks were stacked towards, a lot of that hardware hacking, where there might be some people who are going that are trying to learn about it, but can't necessarily like fully appreciate all the presentations or like understand everything. Whereas this year, they had a fair amount of different talks that also touched on software. Like the one that I gave was low level, but it was still software. There was also a few other ones like firmware security and stuff like that. So again, like it's at a low level and it can involve some hardware, but it has some of the software too. So yeah, everyone that I talked to there and everything was great, and they loved the conference. Uh, I think I said this the last time I talked about Hardware.io, but anyone who hasn't been, I would recommend checking it out. Um, it's just a very chill conference where I feel like it's the perfect size. It's not super small. You're going to be seeing tons of people. Like there was probably like a couple hundred people there at least. Um, but it's still reasonable enough where it's like you don't have multiple tracks going at the same time, and like you're not overwhelmed with walking miles to get to things. Everything's in kind of a contained area, and for the most part, you can do everything you want to do because again, like the talks are single track, and they're kind of spaced out well enough where you can do other stuff as well. So yeah, hardware was a lot of fun. I guess I will take a few minutes to talk about my presentation as well.
Just
So
before you do, want to mention, like, what do you mean feeling overwhelmed? Like, you don't enjoy walking in the Vegas heat between hotels? Like, come on now.
so
What else are you supposed to do? But no, actually, you
yeah, I
talking
mean,
about Hardware.io this time and last time kind of made me want to check it out. It's not a conference that has really been on my radar because you're a lot more into the hardware stuff than I am. I've kind of seen as, hardware, therefore, like, oh no, you've been getting me into hardware stuff. I'll admit that one too, but also just like it sounds like it's a pretty solid conference. Just in general, sounds like there's a lot of interesting stuff going on there. And like you said, a good size where it's not super small. Like there is a good mix. There's that networking. There's like I said, hard and stuff. Like it sounds cool. It's actually something that one of these years I'd like to get out to it also.
I guess what I'd say what really makes it work as well as it does is just how much like care and effort is put in by the people who organize it. Um, like the Hardware.io people and the volunteers and everything, like they're all like such good people to talk to and everything. Like uh, they'll help you out wherever they can, and it's a really good vibe all around. So yeah. It's not like DEF CON where you have like a ton of different goons and like you talk to them once and they, I don't want to like rip on DEF CON too much, but like I don't feel like you get a lot of personal connection with a lot of the like goons and stuff at DEF CON. They're just kind of there to like shout at you and direct you around, which is fine, that is kind of needed, especially at a conference of that scale. But you don't really get like the cool interactions where you can actually have discussions and stuff as much as you do at like conferences like Hardware.io. So it's just, I guess, that difference in scale that allows that to happen. So yeah. And I almost forgot I was going to say this too, but it was kind of funny because Teamstar, which some of you might remember, I did some streams with him on the Day Zero Twitch long time ago on like some PS4 stuff, but he was one of the people doing the introductions for like the talks, and he tried to troll people wherever he could. So I really hope that those trolls are left in the the VODs because they were a bit of fun. He made me like upgrade my demo sort of at the last minute because my demo originally was just going to be rendering the Hardware.io logo when you launch the custom homebrew app. And he was like, so you did all this work to render a PNG? He was like, you could just do this in the browser. And he was like ripping on me a little bit. So
It's a
I
fair
had to
point.
change it a bit. It is. So I had to change it at the last minute to make it so that the Hardware logo, which is like the ladybug thing, would shoot lasers out of its eyes when you hit the trigger buttons. That way it was a little bit less, boring in
Can't you
his
do
words.
that in the browser too? Like that seems like a JavaScript thing.
Actually, you can't because the browser can't access the controller input in the same way.
Okay.
Because the trigger buttons are bound to different things. So yeah, it was able to do something the browser couldn't do. But yeah, there was a lot of fun around that. So getting a little bit into my talk, so I presented a PS5 hypervisor bypass. So I wasn't the only one who worked on this. This was a collaborative effort with mainly with Chendo Chap, and also like Flats helped out a lot too. So this only affected some of the older firmware versions, so it was like 2.x and lower. But there were two vulnerabilities that we had discovered in the hypervisor. Mainly, both of them came down to the fact that the early hypervisor implementation for the PS5 was very naive. I think it kind of highlights that Sony was very new to like secure virtualization. Now they weren't entirely new to it because like the PS3 had a hypervisor and stuff, although I don't think that was a particularly secure implementation either. Um, but compared to like Microsoft and what they've had to do with like Azure and Hyper-V and all that stuff, like Sony is quite a bit behind. So their earlier hypervisor versions were actually embedded as part of the kernel executable. They were in the kernel elf, and the kernel was actually responsible for initializing the hypervisor too, which is sort of a problem and was another bug that Flats had pointed out. But yeah, because you had the hypervisor embedded inside of the kernel, including like the code that it runs and everything, the first bug that we abused was the fact that the jump tables used for like switch statements and stuff in the VM exit handler were accessible to the guest. Like the guest had the mapping to those jump tables. So by corrupting them with like a kernel read write, you could actually just straight up get code execution in the hypervisor when it would go to whatever entry that you hijacked for a switch statement. So we hijacked a particular hypercalls entry, the set CPU PS4 one. And then we had to ROP from there to basically disable nested paging to make the hypervisor useless as a security mechanism. So sorry, you're going to say something there, Z?
I think you kind of answered it. I was just going to ask, were you able to do like pure shellcode, or did you have to go raw? Like, which presumably here you had to go raw since you mentioned ROPing. I was just wondering
Yeah,
where you could
so
point it, or if you could kind of similar no, were you able to point kind of did the ROP chain have to exist in like a stack area for the hypervisor, or was it could you
no,
like basically pivot into where you can already write with the kernel?
yeah, so you could pivot kind of wherever. But yeah, we tried shellcoding, but it's not really possible because the hypervisor's page tables are only going to have the kernel.txt region mapped as executable, and we can't write there, right?
Yeah.
Like write protection is enforced and everything. So because of that, like even if we go into the kernel's guest page tables and we try to add like an executable region, the guest kernel might be able to execute that code, but the hypervisor can't, right?
Yeah, that's more or less what you'd kind of
Because it's going to have
expect,
its own
but
page tables. Yeah.
yeah.
So yeah, that was the first exploit chain. The second vulnerability was a lot more funny and was a bit of a meme because the hypervisor's initialization code would call into this function that would check if the system level debugging flag was set in the QA flags. So this is something sort of specific to PlayStations, but they have these special flags called QA flags or QAF. QA here being quality assurance. They're mainly used for like enabling debug functionality on certain systems. So things like the debug menu are in the QAF, debugger flags, like store testing and things like that. The system level debugging flag is particularly useful because it's checked for like logging and stuff. So if you set it, you can get some more verbose logs, which can be really helpful when you're trying to do stuff. But what was funny was the hypervisor's init code, when it was building the nested page tables for the kernel, um, and I guess I'm kind of using this term nested page tables. I should probably explain a little bit what I mean by that. So I don't want to go through like all the specifics of paging, but the whole idea with paging and virtual memory is that you have page tables that can translate virtual addresses into physical ones. And in the case of no hypervisor, that's pretty much all going to be done by the kernel. So if you have like a kernel read write primitive, you can kind of change mappings very easily. You just find where the page tables are and you change the entry for that virtual address to point to some other physical address. The thing is, if hypervisor is in play, they can take advantage of nested paging, or in Intel, it's called second level address translation, or SLAT. So the idea there is the hypervisor is going to basically shadow the kernel's guest page tables so that when an address translation happens, the kernel isn't the final say anymore. So the kernel, like the guest kernel, will have a guest physical address, which then translates into a host physical address in the hypervisor's nested paging. So that allows the hypervisor to enforce permissions on the pages and where they actually point to. The guest kernel doesn't have full control over that anymore. So basically what I'm saying there is, if you have kernel read write and you try to change the page table entries, that doesn't necessarily gain you capability anymore, because that when it goes through that second level address translation, presumably if you haven't compromised the hypervisor, there's still a layer that enforces what the permissions and everything actually are. So yeah, getting back to the second vulnerability here. So their code for constructing the page tables would check if the system level debugging flag is set. And if it is, for one thing, it wouldn't set the execute only memory bit on the kernel pages. So it disables execute only memory, but it also makes the pages writable, even though they're code pages. So that's sort of a funny thing. It's obviously left there as like a debugging sort of backdoor deal for them to test things. Initially this doesn't seem like it would be a big problem, because this hypervisor init code, it's going to be run close to boot time. Like it's going to be run pretty much immediately after the kernel and everything boots. We're getting control of these flags quite a bit later, as we're exploiting from like a WebKit exploit as the entry point. The problem is these flags are just kind of left as they are and copied back over from the hibernation file when you resume from a sleep state. And these flags are also shared with the guest kernel, just like the jump tables are. So if you just like run the exploit chain, set the system level debugging flag, which we already did because we wanted the verbose logging and everything, you could put the system to sleep, resume it, and then the nested page table entries are going to be marked as read write. So you can just change the kernels, like the guest kernel's page tables to match, and you could just read write to kernel text pages. So very easy exploit. It's a lot easier than like ropping and everything. So that was the like primary method that we used. And then I also briefly cover a bug that Flats had mentioned on Twitter about a week or so ago. Actually, I guess it was a couple weeks ago. But again, some of you listening might have been able to pick up on the fact that like the kernel being responsible for initializing the hypervisor is kind of stupid. It's backwards. Like it's in the chain of trust. It doesn't really make sense. And Flats's bug kind of highlights that, because the method he had was related to Advanced Programmable Interrupt Controller, or APIC. So the APIC object had like an operations table, which is in the kernel's read write data section. Like we can access that. And it has a function pointer that gets called at boot time by the kernel before the hypervisor runs. So if you just replace that function pointer and make it invoke, your own ROP chain or whatever, or even shellcode, you should be able to shellcode, because the hypervisor isn't in play at this point. You have full control over the page tables. You could get code execution at early boot before the hypervisor runs and just tell it not to run the hypervisor. Like you could just like patch that code out. So yeah, just kind of taking advantage of some of these silly issues with the way the hypervisor was architected in the earlier firmware versions. And yeah, so that was pretty much what we had presented. It was a good bit of fun going through talking about them, and Sony still has the occasional meme issue, as these kind of demonstrate, but it is mostly on the older firmware. So it's mostly good for like people who want to reverse engineer the system. Now they can finally do that. They can finally dump the kernel text. That's a public thing now. Whereas for a long time, there were some kernel texts that floated around, but they were not very accessible to the public. Now, people can reverse and try to find bugs and things that could apply to later firmwares as well. So yeah.
Yeah, that's kind of a big deal, because you've mentioned exotext here and execute only memory, but like that's kind of, I think, one of the big, at least in my mind, and I'm not doing the PS5 work, but execute only memory is kind of one of the big defenses that PS5 was able to introduce here, which just hinders the security research by making it so that you can execute this, but you can't actually read. You can't read the code you're executing. You can't access that. So yeah, having that kernel dump feels like it'll enable a lot more research, where, research, even if it's a dump from an earlier kernel version, now that people can have that, there's a potential to look at that to find other vulnerabilities that would
For
still
sure.
apply. So yeah, feels
Absolutely.
like,
Yeah.
even though it's old, like it's opening doors.
Yeah. So yeah, I was really happy with the presentation. Hopefully people will enjoy it when it gets published. It's a little bit funny. The beginning of the presentation, I'm not very visible, so I think their camera was a little bit lower this year. Because how their setup works is they have like the seating area, they have the stage, and then behind the seating area in the center, they have their like audio mixing and recording setup and everything. So it's kind of like straight down the middle of the aisle. But I think their camera was a little bit lower this year, and my laptop is pretty big. It's almost comically big compared to a lot of the laptops other people used to present. So I think I was kind of hidden behind my laptop a little bit for the camera view. They were trying to tell me to move for a couple minutes before I'd actually picked up on that. So a few minutes later, I move into frame and everything. But yeah, there was some funny stuff with it, but overall it went pretty well. And uh, again, when you have sort of these smaller conferences where you've already like met and talked to people and you can spot people in the audience that you have chatted with, and it makes it a lot more comfortable to present, I feel like, than it would be at like DEF CON, for example, where instead of a few hundred people you have potentially like 1,000 people or whatever, and it's not as personable. So yeah, I really like presenting there as well, and hopefully, I'll continue to do so on some future stuff. So yeah, so that's everything I have to say about Hardware I/O. Continuing on a bit of the conference discussion, we are a little bit late to this, but DEF CON had also put out their talks 12 days ago. So Z and I did not go to DEF CON this year. It was a little bit weird. Our summer was a little bit busy with some other stuff, and DEF CON had also switched over to being at the conference center instead of at the hotels. And it just, I don't know, the last time I went to DEF CON, I think we kind of ranted on it a little bit on the podcast, but I just don't really enjoy DEF CON as much as I do some other conferences. It just feels like it's grown too large. So I didn't really go check it out. That said, I have listened to some of the talks that were given, and some of the talks that were given were pretty cool.
Yeah, with this year with DEF CON moving, I kind of figured I'd give it a year to see how the dynamic of the conference changes, being at the conference center now. Because a big thing for me with DEF CON is just meeting up with people, having those sometimes
Yeah.
casual meetups or impromptu meetups. Uh, but it's just kind of seeing people that way and like having that. And whereas when it was split at like a hotel or between a few hotels, there's a chance like, hey, meet up at a bar, meet up here, there, like on the way outside of the conference, and like much more casual than like being in the conference center itself, and like everything's a lot more contained, I guess.
Yeah.
So yeah, I wanted to see the kind of this year. I kind of stayed away, see how kind of the dynamic changes, and maybe I'll go next year. But yeah, I mean, the size aspect, like I see DEF CON as just kind of the get together where everybody's there, so you have the chance to meet up with people, and not so much about the conference itself. It just happens to be that people are attending the conference, but that's kind of changing too, to be honest.
Yeah. And we actually did quite a bit of a discussion on this and like our speculation on how the changes would work and all that. That was on episode 241 for anyone who's interested. It was right at the top of the episode. Um, the topic is titled DEF CON was canceled because the actual original like catalyst for moving to the conference center was that Caesar Entertainment Group didn't renew the like contract or whatever with DEF CON for continuing to run them on the Caesar properties. So that was why they had to move all of a sudden. Although it was kind of also forced on them because DEF CON just keeps growing and growing and growing. I don't know if they put out the numbers for this year, but I believe last year it was in the neighborhood of like 28 to 30,000 people going, and you're kind of outscaling hotels at that stage. So
I think even 20 to 30 feels like that might be low because of COVID and all of that too. Because I'm pretty sure they
yeah,
had higher numbers in the years prior to COVID. I
yeah.
don't know for sure, but I feel like there's at least like 45 or something in years before. So I mean, maybe I'm just not remembering correctly at all. I'm actually just trying to look it up here.
Yeah.
Um,
But while you do that, yeah, episode 241, we talked about that a little bit. But as I say, we have checked out a few of the talks. The most of the talks that I've checked out so far have not been super technical. They've been a little bit more meta. I think Z has checked out a few more of the technical talks, so we'll have a bit of a mix there. Do you want me to start off, Z, with talking about some of
yeah,
the
go
talks that I've
ahead,
checked out?
and
Okay.
I'll jump in if we overlap, or otherwise we'll just follow you up.
All right, cool. So, one of the talks that I thought was pretty interesting was Spies and Bytes, Victory in the Digital Age. So, this was a talk given by the general and I believe current commander of US Cyber Command. He had made a point in this presentation saying that he wanted to, like, I think he's planning on retiring, but he wanted to give the presentation while he was still actively like the commander of Cyber Command because he wanted to use it as like a way to push changes. And like the bureaucracy of what goes on there. But yeah, in that presentation, he talks a fair bit about like the NSA, Cyber Command, and the US government and how their goals and priorities have kind of changed over the years and what major events led to those changes. So there's a fair amount of high profile attacks that were featured. Solar Winds was one of them, of course. Another one was Operation Buckshot Yankee, which I believe was in like 2008, 2009. That took place after it was discovered that like Russian APTs had compromised certain intelligence agency systems. So yeah, there's just a lot of neat information in there. Obviously it's not going into like super classified information or anything. It's a fairly high level overview of it. And it does sort of turn into like a recruiting talk where they're talking about wanting to extend their outreach. They're hoping that the Cyber Command commander will give a talk at DEF CON like every year going forward and kind of make that a regular thing. And they're hoping to recruit more uh, you know, hackers, for lack of a better word, into Cyber Command and whatnot, and trying to extend their capability with that. So
So
yeah,
if
just
they
a cool talk. Though I think even though it was a bit of a recruiting pitch, I think there was still quite a bit of interesting information in the talk, and you get a little bit of insight into the bureaucracy of like how some of that works when it comes to like government and espionage and cyber capabilities.
Yeah, sounds like, make it a yearly thing, make DEF CON, new propaganda source for the government to recruit. No,
It's very funny. Sorry, I'll just say this really quick. It's funny how the government's stance on DEF CON seems to have changed over the years. Like I remember in the 2000s, I didn't go to DEF CON in the 2000s to be clear, but I remember like there was like the Spot the Fed competitions and like there was sort of an adversarial relationship between government and DEF CON, and that's changed quite a lot over the last like decade.
I mean, General Alexander Keith, he gave a presentation. I don't recall the year this happened. I feel like it would have been, maybe a year or two after Snowden dumps, kind of having the chance there. And he just straight up lied there, ended up lying, I guess, in Congress. I don't know all the details on that. I wasn't exactly paying all that much attention at that time. This was during like the mid 2010s, but like that's kind of US politics, so whatever. But I remember that as being a slight turning point, actually, kind of against military. Like I'm not sure if there has been a talk since that one, which, as I recall, it went pretty poorly. Like with having somebody from the government. And I know they actually had a year where they asked like no feds to attend also. And that
I vaguely remember that.
I'm trying to see if I could find that, but like, yeah, there has been, I think in general. So like, if I go back and just think about my own history in general across the scene, like there was a stronger, anti-government and even anti-corporation kind of slant, and that has really shifted over the years.
Yeah, there was a lot more like fight the machine sort of mentality back then, whereas now it's sort of pretty collaborative, honestly.
Yeah, there was
between.
a law, like, and in fairness, like, yeah, people were against the government, but also the government was like, this was also a time where people were being arrested for some very stupid things, and also people were doing stupid things. But like, there was like a law, there's some reason for that adversarial take, but also just like, people didn't like, white hats because they were profiting off of, the work of others. Somebody else writes an exploit, and then this white hat comes along and, makes a profit off of that exploit script. Like, there was that, there's been that shift just in the community, I think, as a whole, where things have become a lot more kind of professional and accepting of that side. And a lot more interest, I think, in, being able to utilize these skills in support of the government for some people. And I mean, Mudge and some of the core uh people behind DEF CON did end up working for the Fed. So like it's not like it's I guess an unexpected collaboration.
Yeah. But yeah, I mean, that's a big part of what that talk was about, was basically trying to create a bridge between government and the kinds of people that attend DEF CON, and kind of extending an olive branch, so to speak. So yeah, I thought it was a pretty interesting talk. Again, like nothing really too technical in it, but I think it would be worth it listening for a lot of people out there. Another one that's a little bit closer to what we typically cover on the podcast that I listened to was Reflections on a Decade in Bug Bounties. And what I thought was cool about this talk was they had
That
an
one is
interesting
a main
dynamic.
stage. That one was
Yeah,
somewhere
it wasn't a
else.
main stage talk. I'm not sure which track it was on. But that talk, what I found kind of interesting was they had two presenters. One of them was is a triager at Synac. And then the other one is like a bug bounty researcher who submits reports. So you kind of have both sides being represented, and it wasn't so much like a formal presentation as like a sort of discussion between the audience and the two that were presenting. So you kind of have a bit of insight into like the, again, sort of adversarial relationship that can flare up between researchers submitting things and triagers. Some of those like frustrations and a lot of the things you can have with like duplicate reports and misunderstandings between triagers and reporters and trying to make your reports clear. uh, there was a lot of that being talked about, and just kind of like tips, I guess, to avoid hitting those situations, and also just trying to get you to reframe your thinking of like, if you're told by a triager like, hey, we don't think your issue is impactful, it's easy to take that personally and think like, these guys are just, they don't want to reward me or whatever, and they're trying to find a way out of it, which, in some cases may be true. But what the triager had said in the presentation was basically, think of it as pushing you to be better, and like, um, making sure your reports are more clear and kind of showing uh, the impact that way. Like basically seeing it as a way to improve everybody as a collective. So yeah, there were some interesting points in there, especially for the people who listen who do like the bug bounty research. I think that talk would be interesting if you haven't seen it already. Uh, Again, I think there are some case studies and like some example vulnerabilities that are shown off, but it's mostly like a meta level talk.
Well, on the bug bounty note, I did not listen to this talk, but I do know that Jason Haddix also did a talk. I think he was part of the AppSec Village. Um, about and like I said, I haven't listened to this one yet. I kind of forgot about until you were just talking about the bug bounty stuff. But yeah, the dark side of bug bounty, which I have heard was a good presentation. I've definitely seen it linked around a bunch, and just looking at the playlist for AppSec Village, yeah, it's definitely been linked around because most of these talks are like, 1,000, 2,000, or some hundreds of views, and then you get to his talk, 32,000 views. Though Jason Haddix being a well-known, content creator, bug bounty hunter, like, not surprising that his talk would just get that attention. But yeah, I'll just mention that I haven't seen it, so I can't really talk too much about.
Yeah. Another sort of fun talk that I enjoyed was, so you want to know how to make badges. This was a little bit like less talking like it wasn't really talking about vulnerabilities or security or anything at all. But from a hardware perspective, I thought it was kind of interesting. Obviously with DEF CON, the badge culture and stuff is a big part of it. And like making and selling custom badges and add-on badges and everything is a big thing. And this talk went into not only like how to design badges and ship them with like designing the PCBs and everything, but also the managerial side of like, how do you manage your budget for building a badge and what considerations do you need to make, like looking at like power demands and do you want the badge for like how long do you want it to be able to run for, especially if it's running off of non-rechargeable battery, you know basically all the design considerations you have to take into account when you make badges. So I found that to be a fun presentation,
Yeah,
and some of
that
the
doesn't
hardware
look
people
like
will like that.
it was main stage either, was it? Because I'm not seeing it
I
in the
think it.
playlist.
Mm,
It's
yeah, maybe it
yeah.
wasn't. I thought it was like because I didn't really go through the playlist. I just judged it based on like the background of the speaker, and it looked like it might have been main stage, but it was kind of hard to tell. So maybe it wasn't. Um, Finally, the other presentation that I watched was kind of close to work that I do, and it was by the IO Active guys, and it was on AMD Sync Close. So I don't think we really covered that on the podcast, but it was basically a vulnerability with SMM and the fact that if you could control certain machine state registers, like the masking and stuff, you could actually overlap the memory mapped IO for a device with the secure segment in memory that's used for system management mode. And by abusing that, you could kind of actually hijack the boot process. Like you could do like bootkit level implants depending on which like if secure boot was enabled and stuff like that. But yeah, very cool presentation. The IO Active guys put out some great stuff, and they've been doing the AMD research for quite a while at this point. And it's one of those issues where it affects like almost all AMD CPUs. There are like ways you can mitigate against it, and they talk about some of those ways and whatnot. But a lot of vendors, especially in like the laptop space, like apparently they don't even enable secure boot and stuff, which is just kind of wild. But the default security settings on a lot of vendors is very, very weak. So a sufficiently privileged attacker that could take advantage of this bug could do some like lasting damage potentially, subverting secure boot and gaining the ability to write to the spy flash, because the system management mode has like the spy controller and everything inside of it, like it can access it. So yeah, some very interesting research. I believe they might have presented this at Hardware as well, but it was one of those presentations that just I couldn't really catch because it didn't fall in a like time slot that worked out. But yeah, they've been presenting this research, and it's very cool. So if you're interested in those lower level issues and SMM and stuff like that, uh, again, a great presentation. So that was the main ones that I watched. Z, I know you watched a few different ones, so I'll let you get into those.
Yeah, it doesn't seem like we had too much overlap there. I will kind of mention here, I just noticed this, that Cory Doctorow also gave a talk at FCon 32. I'm not sure if I was aware of that or if I knew and forgot, but that's another one to check out. That's going to be like not high level, or sorry, not low level, like vulnerability focused at all. But I was a fan of his little brother book, and I think he has made a name for himself well beyond that in the years since that book. But also the guy that coined enshittification, if you're familiar with that term or not. But looks like he has a talk, so I'm going to want to check that out. I have not yet, so can't comment on that. What I did check out, though, I think unsurprising to Lofty, is I did give Garrett Hayes' talk splitting the email atom, exploiting parsers to bypass access controls. I am always going to look at anything coming out of the Portswigger team and their research. And there was a post about this also, so like a lot of the information's kind of covered without needing to watch a talk, but I did check that out, and it's just a cool talk about, as you would expect, exploiting email parsers and the complexities of email. I knew some of the tricks with email. I didn't realize that there are comments as part of an email like that. I apparently including something in brackets, like at the end of a domain, then like bracket, like, what gmail.com bracket something end bracket, that's completely legitimate because brackets are comments apparently. I didn't know that until seeing that. I think I noticed that first in the slides, but either way, yeah, there's some interesting tidbits in there. Yeah, just about breaking the parsing, how different parsers may parse a domain differently. And of course, there's a lot of security that depends on having it like validating an email, and then, oh, this email matches this domain, add them to like this privilege group or that group or whatever. Like there's a lot of security that comes down to just parsing the email. So attacking that, which yeah, was a cool talk. And I mean, generally speaking, a lot of the research coming out of Portswigger is always pretty solid. Another one that was kind of interesting, SQL injection isn't dead, smuggling queries at the protocol level. This one is kind of an often forgotten layer of kind of the stack and attacking that. So, when we think about SQL injection, oftentimes it's looking at, for an application, they'll write code, they'll write a query, they'll write that query insecurely so that you can inject content into the query. Instead of going for that, this is kind of more attacking the driver that communicates. So in whatever programming language you use, you'll have some function you're calling to actually make your queries and actually perform the query or prepare a query with the backend server. And it's going to speak the protocol of whatever the database is. It's going to speak the line protocol, or it could be speaking the line protocol, or it could be speaking a binary protocol. I know MySQL has both. I assume others do, but I'm not actually certain about all the implementations. Either way, it's kind of looking at attacking that driver code and the actual implementation at that level. So they end up talking about like a integer overflow in one of the Postgres drivers, where basically using that integer overflow, it would package up its data for the binary format going over the wire, it would have like a TLV or type length value sort of deal, and it would be like, okay, this is this type, and it's had 4 bytes for the length. You could overflow that, giving it more than like 4 gigabytes of data for a query, and it'll just wrap around but still have 4 gigs of data. So it reads that as like a smaller size, and then it tries to parse another TLV value, and you can actually inject your like a completely new query that way. Just a cool layer of the attack, interesting approach. And it's one of those areas that you don't necessarily think about a lot. You just think, okay, it's communicating with the database. You kind of have that focus there and not really too focused on that glue code that exists. So I thought that one was interesting. The last one that I kind of found interesting, maybe some of you will find this interesting also, maybe not, but it was a troll trapping through task tools exposing speedrunning cheaters. And it wasn't like super security folks at all. This was just some of the analysis they did to uncover some cheated game runs, speed runs. This was from, I forget his name now, but he does the Tazbot. If I can type here, Alan Cecil. Yeah, his handle is slipping my mind right now, but either way, I thought it was interesting. I enjoy that sort of content. Like I watched a couple YouTube channels, or one primarily, where they'll talk about like how they detected certain runs were fake because Mario's blink rate was wrong or something. Like those really small details, I kind of like seeing how they figure that out and then apply here.
It's very cool.
Yeah, it's very deep knowledge of the games that's required. So like there is kind of that overlap, but it's not strictly security, but definitely still interesting, low level. And yeah, went into a bunch of stuff with this as they looked at like a Diablo thing. So yeah, I found it interesting, not security related, but still I think pretty cool.
Yeah, it's a fun application of forensics, and like cheating has always kind of been a hard problem to solve, but for things like speed running and stuff like that, like it can be even more difficult. I am not super deep in the speed running community or like record communities, but I know they do have a lot of requirements with like making sure you have footage of everything and sometimes even audio and having that all available and everything, and trying to spot like jump cuts and stuff can be hard, never mind actually like tampering with the state of the game. So Yeah, it's pretty incredible that the amount of work and stuff that people go into catching people who are trying to cheat the speed runs. So, uh, yeah, I mean, I know a lot of people get into like security and hacking and stuff because of games. So I imagine a lot of people would find that interesting, and that's actually a talk that I kind of want to go check out afterwards, after we finish recording, actually.
Oh yeah,
So
and the game hacking to like professional stuff, that pipeline definitely exists, and
yeah,
a lot of people move down that route. I'll just mention also, since I mentioned I watched some other YouTubers, Carl Jobs. I probably don't say his last name, but that's the other YouTube channel that I see some of that sort of content on. If you guys want, I feel like anybody who's interested has probably already seen him because it's a much larger channel than we are. But nonetheless, I enjoy that content. Sometimes it's detecting the cheats. Other times it's just breaking down like some of the tricks that are used in speedrun, which can include memory corruption bugs sometimes, where they'll be exploiting a game bug in a speedrun. So I don't know, there's some overlap. I enjoy that content, so I'll shout it out.
yeah. But yeah, I think that's pretty much everything we have to say on DEF CON. Again, we can only really talk about the talks we've seen. We didn't really go. Maybe next year we will after, I haven't really talked to anybody about how the conference actually ran. Have you? Because
No,
like
I
I remember we were
haven't.
left with some questions about like how well it'll work, especially with like that casual meetup and stuff. And I most of the people that I usually meet up with at DEF CON just didn't go, like same as we didn't. So
Yeah, that's I do know some people that went, haven't really talked to them. Maybe I'll reach out and get some opinions there.
okay.
But yeah,
I
I
guess I will say,
haven't.
like, anyone who listens to us, if like you went to DEF CON or you know someone who did, feel free to leave like what your thoughts were on how it ran, because I am curious and I never really heard from people who went, so I'd be interested.
Yeah, so would I.
Yeah. So moving into some topics. So this is one we've kind of had on the back burner for a little bit, but it's pretty interesting because it talks about file system and basically how hard doing like having secure access with file systems is, particularly because of all the differences that you can have between different operating systems and the fact that POSIX really isn't that great when it comes to file system stuff. So Z, I'll let you get into some of the content here.
Yeah, like I said, we have been passing this one off from episode to episode to episode, thinking, oh yeah, we'll cover it next week and next week. Like, I feel like this was actually going to be one of the topics that we covered on like the first episode back, or like maybe it was the second one, but like, yeah,
It
we
was close
keep
to it.
passing
Yeah.
this one off because it is such a dense topic here. These are, as I say here in the intro, these are the technical slides that they always have to cut from their presentation. So their actual presentation, you found a link to that, I believe, which was focused on OS X or like Mac OS.
Yeah. Yeah,
Things
it
there. I'm
was
just
given that
pulling it up.
objective by the sea. So that's like pretty much all Apple stuff.
I thought I was pulling it up, but I had the wrong link copied.
I do have it if you
So
need.
yeah, well, we can add the link in the show notes. Either way, yeah, it's a oh, you've got it here.
Yeah.
Yeah, so basically file system attacks on Mac OS. So this is the removed slides, and there is a ton of information in this. I have lost. There's the original post again. This really is, says here, a brain dump of everything I know. So there's no chance we're just going to talk through everything, but there's a ton of information here. Things that you may realize. Some things are maybe a bit surprising, maybe not a bit surprising. Talking about, how access control lists end up being inherited, or how basically the whole thing works here. It is a wealth of information, including some of the attacks, some of the issues that they have found, and like the attack surface that they've seen from this. Some of the APIs looks like just a wealth of information. So this is maybe a bit of a shout out rather than covering this in depth. And while it is technically macOS focused, there is going to be overlap, because it is POSIX or POSIX or however you say that. Although they do actually call out Linux is not fully POSIX compatible, neither is FreeBSD, but there are, and neither is macOS, but there are overlaps that are going to exist with all of this. And it's just it's a attack class that I don't think a lot of us really think about, because if you're doing web, you're maybe not thinking about the file system very much, because that's remote from you. You don't really have access on that to pull off any of these sort of attacks. This is the sort of thing that's going to be looking at more like local privilege escalation, which is a bigger deal on Mac OS, where you've got like TCC, the what's that, like transparency something compliance, or I forget exactly what it stands for, but they have some of those subsystems in play over the files and a lot of those things. So yeah, I mean, it's an interesting area. It's kind of a boring area in some sense when you're looking for these bugs. Like, can be kind of tedious. But yeah, ton of information here. So I just want to really shout it out as a uh resource to take a look at, inspiration for attacks, just and understanding. So this is the stuff they have to remove because it's too technical from their main presentation. And yeah, it is a wealth of information here. I'm glad we're finally getting it mentioned on the podcast.
Yeah, it's sort of these like file system bugs are sort of their own area because you have sort of those higher level like web and application logic type issues, and then you have memory corruption, and then you have file system sort of in the middle. And I wanted to comment a little bit on like the Mac OS portion of it, because kind of why Mac OS is a little bit interesting too is when it comes to file system stuff, because it can be like so dangerous and you can wreak so much havoc with it on like Linux or BSD or whatever, you're not really going to be able to mount custom file systems without permissions. That is considered a privileged action. But on macOS, even unprivileged users can mount custom file system images, which can kind of create its own problems, because then you can create like impossible file system structures. You can have files that have like mismatched links and link counts and things like that. You have even more interesting file system races beyond your typical like symlink style races. And like macOS relies pretty heavily on file attributes for security, but you could just mount a file system that doesn't support extended attributes. So you have a lot of really interesting interactions that can happen on the file system and between different file systems and stuff like that. So yeah, I mean, as Z said, there's way too much like different specific things to cover here, but it's great at giving you like methodology and like some ideas for kinds of things you can look for if the file system is in scope of what you're looking at. I think these slides could be a great resource for getting some inspiration for doing some of that work, and giving you some ideas that you might not have thought of otherwise. Like another thing, for example, that kind of jumped out at me was resource forks. They have these slides that are a rant on resource forks, where you have a path where, you know, it's like /a/dot file name / another file name. You know, typically that would be interpreted as, you know, a regular path, whereas in macOS, uh, it's not. Like this, the file is taken as a resource inside of another file instead of actually doing like a path traversal, so it can be very weird. So yeah, I think there's a lot of cool information here, and it's definitely worth checking out if file system stuff is in your purview.
And a fun thing, just since you mentioned the resource fork thing, I believe that is what also brought about alternate data streams in NTFS. So that's on Windows, where if you use a colon in the file name, you can have like test.txt colon something else .txt, and it'll be like a completely separate file that exists inside of that other file. And like you can't really, I don't think there's a way that you can like delete just the alternate data stream. It was used for like embedding icons, and I believe it was because they were trying to be compatible with how Mac OS was doing something. So like that's kind of the origin of this other weird little quirky feature on Windows and NTFS. I don't know. You just remind me of that. It's one of those like really weird features that can be abused for security reasons every so often. But
Yeah,
yeah,
file system stuff is so weird because interop is really difficult, where it's like the file system API and everything should be standardized via POSIX, but POSIX just wasn't good enough, which they kind of talk about here. Like for example, like for following, like, you can't tell the rename function in POSIX not to follow symlinks, which from a security context, that might be something you want to like avoid doing. So you need to use like the extended one, which allows passing flags, but that's not standard. So other operating systems might not implement that or might implement that a different way. And because of all these different little differences you have between operating systems and, with a file system, you need it to be somewhat compatible. It just creates this mess of different issues you can exploit.
Yeah, and I'll just mention if you're thinking about like, okay, but when are you going to have that? Like I mentioned, local privilege escalation is probably one of the big areas where you'll see file system attacks as like a viable thing. And that could be, Spectre mentioned, like mounting a file system, almost like attacking the operating system in some way there. But you'll also see it just with like how different services or like privileged services on Mac OS, on Windows, on whatever, go to read files. And like you can have attacks kind of existing there. Um,
Yeah,
any
particularly
sort
we've seen
of
it with like configuration files or update files or things like that, where you need to cross a privilege boundary, particularly on macOS.
Yeah, like that is kind of one of the main places where I think a lot of these attacks can exist. Although some of this knowledge could be useful even as a web attacker. Like the alternate data stream thing is something you can technically reach if you can control a file name. And it's like, well, I'm going to access uh, this special thing that isn't like a real file, so other things are going to mishandle and like take advantage of that. So it is also useful knowledge beyond that, but yeah, it pops like file system stuff also just kind of pops up in the weirdest of places, which actually is kind of also related to our next topic. I'm not sure how much more we have to say on this one, but
Yeah, no, I think
uh,
that's a great jumping off point. So, yeah, Sonar put out a blog post on why code security matters, even in hardened environments. So, the premise for this blog post is assuming that you have an arbitrary file right. So, the example they give is like, say you have like a web app, and you found like an upload functionality that you can gain access to, and there's a path traversal. So, you can write like an arbitrary file in an arbitrary directory. Obviously, if you can use that to overwrite like some config file or a library or something like that, that can be pretty impactful. So, uh, what various applications will do if they want to have some defense in depth is they'll have a hardened environment. And mainly that involves things like mounting file systems outside of an intended upload directory as read only, which you can easily think of as like a developer and think, okay, I'm safe. Even if someone finds some kind of path traversal or something, any other directory that has privileged files, it's going to have read-only access, so you can't use a write to corrupt it and gain some additional primitive. The problem is that's not really true, as this blog post goes into, because Linux has that everything is a file concept, and that includes special file systems. So one that is like somewhat common and a fair amount of people are familiar with is procfs. So procfs lets you gain access to things like a process's file descriptors via the proc pid fd directory. And these file descriptors include things like named pipes, which are pretty relevant because in like Node.js applications, these are going to be used for IPC or inter-process communication. And there's various structures that are sent across these pipes that include like pointers and function pointers and all these things. And even though you might have like procfs and that directory and everything mounted as read only, the problem is you can still write to things like pipes because that goes through pipefs, not the native file system. So again, calling back to the last topic, you have kind of this interplay between different file systems, and it makes the permission structure not straightforward at all. So with your ability to like be able to hijack these pipes and send malicious data across them, you could send structures with pointers and function pointers that end up getting followed. And at first you're like, okay, that's pretty cool, but ASLR should be in play. It should stop this, or at least require you to be able to get some form of info leak primitive in order to pass a function pointer that does something useful and, runs a ROP chain that does useful things. The problem is, the Node.js binary on Linux by default is not compiled as position independent. They say that this is something that's been raised before, and Node.js claims this is for performance considerations, which honestly just sounds like a load of crap because position independent code does not cost you performance. So
You
it
have
sounds like a
like
bad argument, but
you kind of have because when you go position independent, that basically means now every function ends up being a wrapped call in a sense. So you get like the extra couple of instructions being executed on the front end of all your function calls. So like there is a performance impact in order to do it.
but it's so minimal that like I've never heard that as an actual argument against position independent code, like performance reasons. Like
yeah, like
in modern day systems, like that's insane to claim. But
I'd be interested in like what node's actual like performance. I didn't actually take a look at this link here. If they have like the actual stats on that. Because yeah, I agree with you. In most cases, it is definitely going to be very minimal. And on something like Node, I think you could easily make the, you know, argument that this is something that should have it. Like it is something that deals with external untrusted inputs.
yeah,
Therefore, you want to have all the security on there. Or at least what you can. So I feel like there's a pretty good argument to have it just on that front. I'm not trying to argue against it. But I would be interested if there was something just about how they are run in particular, knowing that they are kind of like the single loop, or not single loop, not even single threaded, but like given the event loop structure that Node has, I'd be interested if there was something related to that architecture that kind of doesn't play nicely with Pi, means, they're doing a lot more calls than normal. I don't know. I'm kind of just tossing things out here at this point. And I don't know, maybe they actually talk about the performance somewhere in here.
yeah.
5 to 10%, it looks like. Which is kind of
Hmm.
significant over the scale that Node.js is running.
That
But
seems
oh no,
high, but I don't want to
yeah, I'm not looking at any of the details
critique
here. I
their
just see
methodology. Yeah.
one post here that's like, I have Pi enabled and you could expect the performance penalty of 5 to 10%.
Hmm.
Which, yeah, I
Okay.
mean,
If that's true, then maybe I'll walk back a little bit and say, okay, that's not insignificant, but yeah, either way, this thing with Pi is just kind of the cherry on top that made this easily exploitable. The root thing that this blog post is getting at is that fact that, like, file systems are not straightforward. And even though it might be mounted as read only, that doesn't actually mean that every file that's accessible is read only, because you can cross over into different file systems and have that sort of issue. So yeah, I thought it was cool for that reason. Another thing that's kind of cool here is you are kind of making that transition from like a arbitrary file write and taking that to like native code execution, which is kind of neat. And it can kind of enable you to get around like sandboxing and stuff that would exist at the node level because you're basically attacking the engine, you're getting actual native code execution. So that's another really neat aspect of it. So yeah, I
yeah,
thought
that
this
was,
topic dovetails nicely with the missing guide to file system security because it just emphasizes that point that it's really hard to get right.
yeah, and I mean, ProcFS is one of those things that gets abused in like, so many CTFs have these crazy, weird little uses for ProcFS. And I remember doing like this Python sandbox escape CTF challenge where, you had to basically you just corrupted yourself through the proc file system. And it's one of those things that can be very abused because everything's a file with Linux. And yeah, it's one. I thought this was a really cool post though, just seeing kind of that transition from here's this arbitrary file right now, let's turn it into more of a memory corruption style attack, or at least going down to that level. Just a really
Yeah.
cool transition, not something you see very often. So worth kind of checking out. Cool attack. And yeah, like Sonar has I followed their blog for a while. Like I've had kind of them up on our feeds for a while, but it's been like this last year or so. They have been putting out some really awesome stuff.
They've been going hard. Yeah.
Yeah. Actually, I think even one of the talks, the SQL injection DEF CON talk I mentioned, that was from somebody at Sonar. I think I might want to double
Oh,
check
cool.
that, but yeah, I think that one SQL injection at the protocol level was also from the seminars. So yeah, they've been putting out some solid stuff.
Yeah. So that's most of the file system stuff all down. Z, I know you have another post that you found interesting, so we'll wrap up with that, and then yeah.
Yeah, this one is, I guess, more of a shout out. My side, I had fun reading this one. So for those of you who know a bit of my background, I for a short period of time before getting my first like security oriented job, I did do uh kind of worked as a game dev. I worked as a cheat developer, bot developer before that, which got me the job for the game that I had wrote bots for. And then I ended up just fully into security. So this is somebody else kind of in the late 2000s talking about they worked at some niche MMO game company, and took on one of the bots there, bought a copy, figured out how it worked, or like figured out a way of detecting it. The way they detected it was pretty easy. It was basically for updates, the hack would keep for updates to protect the updates, it would download all of the it would basically download the hack on the fly. So they would just see like, okay, if you connect here, like to this IP or whatever, this port, you have an open connection to that, you're this bot, like you're this hack. There's no other reason to have that thing open. Like it was a very easy detection, but also talks about a few other aspects like copying data with the bias and like you might see the one right of the data you're interested in, but not the copy data, so you can like detect corruptions in that sense. Pretty old tricks, nothing too crazy. This is more the type of when I mentioned I worked on anti-cheat, people today kind of think about modern anti-cheat, and this was more kind of the sort of thing I did. So I thought it was just a fun read, talking about some of the things both that the hack was able to do and that they were doing. So yeah, it's just a fun read. There's not a lot of security here. I just wanted to give it a shout out.
All right. So that concludes all the topics we have for this week. So again, apologies for this episode going out a little late and not having any last week, but we should be back to regular schedule going forward. So yeah, with all that said, we hope you enjoyed, and we'll catch you in the next one.